Welcome to Made in Science, the official podcast of the University of Stuttgart. Since mid-April 2026, following a small launch event, an autonomous minibus has been running across campus on a trial basis. Perhaps some of you have seen it already. In the future, the bus will provide autonomous, barrier-free service between the Fraunhofer campus and Universität S-Bahn station, free of charge for employees and visitors. This will significantly shorten the roughly 15-minute walk across the campus that faculty and students currently take. Now, when talking about electromobility and vehicles, but also energy research, production technologies, and also medical engineering here at the University of Stuttgart, you will come across one name in particular, and that is Professor Nejila Parspour, Director of the Institute of Electrical Engineering Energy Conversion, IEW, here at the university for more than 20 years. Very nice meeting you here at Made in Science, Professor Parspour. How are you today?
Thank you very much. Thank you for your invitation. I feel wonderful, and I'm so happy to be here, your guest.
Thank you very much. We'll love to have you. When I just talked about the launch of live operations, they always make a major milestone on the path to widespread use of autonomous, say, minibuses in public transport in Germany, as there have been no real world applications outside test routes until now. Mm-hmm. You have also been involved in similar projects like the one that is going on right now. What are some of your experiences from these?
Well, let me start with one experience I did when I was in December in San Francisco. I took Waymo, and I was impressed. I was really impressed what this car is able to do. So I didn't expect this before. And I was like, why don't we have this in Germany? And even this news today, I also saw this news about this autonomous bus. I was wondering, it's really Germany? Did we allow this car to drive autonomously? And my experience is that the technology is now there. And some countries are also say, yes, why not? For example, California, San Francisco, and maybe next year London. Waymo is going to drive in London. And I was so happy to read this news that we also are open to have this kind of driving. But my experience, to be honest, in Germany, we are very reluctant against this kind of innovations. And we start with a prototype, we observe it, and then we stop. We don't continue the innovation. And it's kind of disappointing for me as a researcher to observe this process like this.
But you might be sailing with good wind these days, because a project like this gets the support here in Baden-Württemberg by the Ministry of Transportation as well. And I think perhaps there is a second, wind or second wave or whatever you want to call it for similar projects.
I hope so, because even nowadays we see how important it is to drive electrically without all of this other kind of conventional motors. We know we depend on resources we don't have, but we have wind and we have sun, so we can produce electricity with renewable energies. And it makes us to become very independent of other countries, of any other actions in the world, and things happen. Yes, maybe it's the new wave. I hope.
The new wave. Now, in 2012, you were selected as one of the first 3 winners of the Übermorgenmacher competition, Tomorrow's Makers, for the 60th anniversary of the state of Baden-Württemberg. And that was for your achievement in the field of inductive charging electric vehicles. 2012. Now we are in 2026. How far have we come from yesterday to the day after today? Are we way into the future, or from your perspective in research also, the way you see it, are we still in just today?
2012, I had this vision, and at that time we just had small prototypes in our labs. So we didn't have real cars in our lab. We just had small carts, so toys actually. We had electrified them, and we electrified them wirelessly. So this vision was there, but there was no real prototype, nothing, 2012. So übermorgen, the day after tomorrow, is from the point of view of a researcher is today. So we have electrical vehicles outside. They are able to charge wirelessly and using this technology. So it means that we are at the end of this process to considering this technology as something like principal research. We are in the application. So we can see, for example, buses. Yes, we have one bus line. We have one bus line in Balingen. This bus will be electrified wirelessly during driving. It's great. Not only while parking, during driving. And we have also some car makers in Baden-Württemberg. They have announced they are going to sell cars which are able to charge wirelessly. But it's still too slow, 2012. We are in 2026. We could be faster. But I am happy that from the point of view of science, related to the electric vehicles, we are in the day after tomorrow now.
Now, when people hear wireless power, they often think of smartphones or electric cars. Mm-hmm. Where do you see the most impact applications in the future, perhaps beyond these particular applications as well? Or I'm sure you have worked on some already.
Okay. Yes, we did. I see the main impact, to be honest, in the field of production technology. And I see also in the field of robotics and in the field of medical engineering. Would you like me to give some examples?
Absolutely, please.
So let us start with the field of production technology. So when you go for sightseeing inside a production company, you see lots of moving parts, many moving parts, and most of them, almost 100% of them, are electromechanical systems. So, and we observe many broken wires and not optimal contacts there, and we can replace all of them with wireless power systems. And indeed, we have already started with that. And then we observe the beginning of moving robots, and robots are going to work with us in the production, but they are going to come to our houses and to help us. And also this kind of robots need electricity. They have to be charged. And how should we charge them? Should we put them somewhere and let's say, okay, sleep here, and after 8 hours we will come and pick you up? No, we have technology. We can let them work 24 hours. And that is another field of application. And then I see also the impact in the field of medical engineering, for example, building exoskeletons. They need electricity, and also very important is that they just don't need electricity like electrical vehicle charging one battery. They have different motors everywhere, and it's really challenging to supply them with electricity, because all of these cables, they experience movements all the time. And then when we come to another field of medical engineering, we have, for example, the field of different kind of devices. For example, heart assist systems, which are implanted into the body, and they are so good nowadays that they are just destination therapy. They are not bridge therapy, and they need to get electricity. And how?
In all of this, and it sounds to me like the future is really today already, and really at a within easy reach. Although I shouldn't say easy. Perhaps my question is, from your experience, what are the most important drivers in all of these changes, and what are some of the obstacles that you have encountered or that you see around you?
So the drivers are the researchers and the engineers and lots of non-engineers which are so fascinated of this technology. Sometimes I talk to public people just somewhere, and I see this light in the eyes of the people when I talk about, yes, it's possible to remove all of these cables. And it's possible to have this freedom and also to save materials and so on. I think all of these people who know the potential and what this technology can are the drivers. So, but we have also as obstacles, who are this? Oh, yes. Starting one innovation is one point in research. We are free. We can do this. But bringing this innovation to the people is the main challenge, because you are not alone. You need to have the acceptance in the society. You need to have the money for that. You need to have the companies who think, yes, that is the product for us. And that is something I see, for example, great challenges in Germany, because we are very reluctant and we don't like to have this high risk here. But I don't see this, for example, in China or Asia.
Aren't people more ready sometimes than the regulations around them?
Absolutely. Absolutely. Everywhere I was, people were more ready than regulations. Yes.
For your work to make these kinds of changes going, how important are patents in this process to implement these?
For the people, it's not important. They don't care about it. But that was a very special experience I did, to be honest. During the first years, I tried to work like open source. I am a scientist. Everybody has to have access to the science. And then I came to one point. I saw, okay, we have wonderful developments, but companies are not interested in them. The first question they ask, do you have any patent on it? Why? Yes, it's important. We want to have to protect our products. And since that moment, I started to file patents and patents and patents. And indeed, that is the help. And that's, by the way, and one special application I don't know, are we going to talk about it or not? It's a special electrical motor, which this motor utilizes inductive charging to operate without rare earth magnets. So it sounds crazy. What has a motor to do with inductive charging? Maybe first I could describe the technical background, and then we'll come back to the patent.
Absolutely. Take whatever direct or detour you want.
Okay. So again, almost 10 years ago, we observed this problem of rare earth magnets. And to be honest, people came to us and told us, it gets 10 years ago, it gets expensive and more expensive. But it was not my problem. My problem was that rare earth magnets actually are really critical materials, because not only because they come from China, because their production is really horrible in terms of environmental impact. So, and I really like to get rid of them. But, I actually built electrical motors as well. And I knew that they are the best material to have. So how to replace them? A very old technology is to produce magnetic field using wires, using electricity. Okay, we could do this. It's a very old motor called electrically excited machine. But the electricity is on the moving part, on the rotor. So how to bring the electricity to a moving part? The state of the art is to using slip rings, just contacts. So it's not something I would like to do. And I decided to transfer with my research group. We decided to transfer this idea of charging electrical vehicles to energizing the rotor, the moving part of an electric motor. And it worked. And we filed for several patents and we were happy because as soon as they were granted, first companies came and we could solve this. And now this prototype, this idea is going to be implemented into the future electrical vehicles. So.
Sounds to me like that baseball movie Field of Dreams, where one of the characters says, if you build it, they'll come. Yeah. And I think that could be a somewhat similar example that you just gave us here.
Yeah.
To wind this first approach and round of our questions up, we started with real-world testing. What role can universities play as real-world testing environments for new technologies? It seems to me the real-world testing is still could still grow. Put it that way. What do you think?
Yeah, I think. We actually did the first step toward this direction years ago with the project Mobility Living Lab in Campus Wengen. So during this project of MobiLab, we had the freedom to use the campus as our test site to test everything and because, in our labs, we don't have enough space. So, and there we had a street to demonstrate, for example, wireless power charging of electrical vehicles, not only stationary, but while driving. That's great. So I don't know how many persons came to visit our site. TV was there, radio were there. Everybody was there. It was great. Even now we can find some reports on this street, on this electrified street, they called it, on YouTube and so on. And so it was so great experience to see. And I wish we could continue this work. So unfortunately, after 6 months, we had to remove everything and go back to our labs because it was just a place for cars. And the street we had was actually previously was, I think, there was slots for parking slots.
Parking lot.
It was a parking slot, yeah.
Okay.
And so they told us, okay, after 6 months, so we need the space again. So we moved back everything to our labs. But we were so sorry about that because actually why? Why it was not, we should start again. And it was too much work, to be honest, to prepare everything, to bring this technology to the street. And, for example, to demonstrate it's raining, no worries, it works. We had also snow and it worked. And people saw, wow, it's working. And I wish we could have more of these opportunities.
Yeah, so reaching out to the user, to the potential future user, and also in the near future, user, and to make everybody understand.
Yeah, so unfortunately, we start very early with our technology. For example, also Transrapid. We had this prototype during my study in Berlin. We saw it working. It was 1990. Okay, and where's Transrapid now?
Well, sometimes in the news again these days, you never know what will come out of that one.
Yeah.
Now, people, that's what I just heard in your answer as well. People are important, and people means women and men. In your area, in engineering, in Germany, how has the situation for female researchers and also female students in engineering, in your perspective, developed over the past decades that you've been working at academic institutions here?
If you mean with the development, increasing of the number of the female researchers, I would say almost steady state. So unfortunately, I don't see any significant increasing of the numbers of the female researchers or even female students in Germany. So it's for me, a very sad situation, because I know that it's possible to work within this field as male or the female person, but I don't observe it.
One way when you try to address this issue is also are also your activities at STEM, covering the topic STEM, science, technology, engineering, mathematics, the MINT schools that exist in Germany that compete for MINT school title as well. You have done. I saw a YouTube video where you explain topics to the general public, but in particular pupils as well. What do you think? Do we need more of the same? Do we need a different approach when it comes to pupils to make them familiar, everybody, with the topics in your field?
Mm-hmm. Yeah, it's a great question. I think, I have been in this field now for 2 decades almost, also longer when I take into account my study and so on. Now I would say all of these programs, they have just limited effects on what we want to achieve. And they don't play the main role. It's nice to have them, but they are not going to change the problem. We have to accept that it is a problem, because we need engineers, we need males and female engineers, we need engineers. But we don't have them. That is the problem. And showing them how nice the job is, how great this job is, it's not sufficient. As we can see, it didn't help. So I would stop most of these activities, and I would go back to the schools, and I would try to teach in a different way. Mm-hmm. Maybe in an old-fashioned way. We will learn everything in mathematics and physics. We need these 2 main topics. And when I see what the kids learn nowadays at school, it's not enough, not at all. There's no time to exercise and to understand. And they don't understand the material. They don't understand the mathematics and physics. And then after a while they say, oh, it's mathematics, not cool. I don't like it. They don't like it because they don't understand it. That's the main problem. I would try to solve that problem first, because it is the beginning of everything. And it continues when they come to the high schools and they see, oh, physics, mathematics, I don't understand anything. Let's go for for most of the cases, just for to negotiate with people, learn presentation techniques and so on. We need all of them. But for engineering, we need mainly physics and mathematics.
You have already mentioned the people and the pupils. Now, I wonder, what skills or mindsets will be most important actually in the future that should be developed at school? I also ask because I remember some years ago in a campaign, former Chancellor Merkel got this question, and she basically said, well, pupils would need to know reading and writing and calculating. And then there was a slight moment, and then she added also programming computer software. What would you add to this list or take off?
Well, I would maybe first take off the programming because it's one skill. First, it's changing very fast, and also, I have taken over this task, but I would never remove calculation, writing and reading, and I would also add natural sciences, and maybe I would also add social sciences, because it doesn't help just to become a wonderful engineer. You have to know for what is something good. Maybe, I don't know, you could also cut it out. But during my study at Technical University of Berlin, I arrived there with this idea, it's a technical university. We are going to learn all the time mathematics, and so on. And it was indeed, my study was electrical engineering. We had all of this mathematics and exercises and physics, and of course electrical engineering, hardware a lot, software a lot. But I was all the time wondering why we are meeting so many people when we are walking from our labs to the Mensa, talking about the politics. We met them. They were students. They told me, yes, we are studying social science and so on. I was saying, why at a technical university, why they offered social science? And I asked one professor, very old one, he told me, yes, we don't like to have engineers who are going to build atom bombs. We want to avoid this. And it was great, because up to that time, I was like, I only love electrical engineering. But suddenly I saw, for what I am doing this, it's important, because we need both technology, science, and the humanity.
And the humanities as well, where you're talking here to somebody in that field for sure. So that the ethical dimension, also at our university with the International Center for IZKT, that brings together the sciences and communicates within the university and outside of the university on these issues.
Great.
Is important. Taking up the idea outside the university. You have also worked in industry for some time. Perhaps you would like to share some of your experiences from that particular phase in your life.
Oh, yeah. Well, actually, to be honest, I didn't like to go to an industrial company, but one of my professors told me, you have to go. You cannot stay all the time in science. If you stay with industry for just a few years, you will come back and work in a different way. And he was right. It was a great time for me. I was with the company Philips. In the beginning, I used to work as just a normal engineer to develop robotic systems and to write programs. But then I came in contact with the real life, because we had to prepare something and sell this thing. And then after many years, I became just a project manager, and then I had more responsibility, and I was also responsible for return of invest. So for profits, for all of these topics, I was never interested in that. But I knew to be able to survive, you need a combination of both. Only building and selling and making profit is one point. It's just only one condition to be successful and survive. You have to bring innovation. And the combination makes you become the best of the world. The combination of working perfect and bringing all the time innovation in parallel. And that is something I learned at that company.
So that's the industry-related period in your life. Now, what about your stays outside of Germany? You were in the US, I understand, and suddenly you brought international experience with you already.
Yes. So thank you for this question. Yes, I was during my postdoc in the US, and I was also in Brazil during my postdoc, and I also was really, I was happy. I had a very nice supervisor during my PhD, and he just told me, you can do everything. Just go and represent this work and this. And I traveled a lot. And Yes, your question was my experience.
Your experiences, the perception, perhaps the approaches that you got to learn or saw at other universities abroad.
I learned a very nice point. I learned German engineers are the best of the world. It sounds crazy, but
it sounds very true to me.
It was so I arrived in Berkeley. You think UC Berkeley, wow, what I'm going to experience there. And I saw indeed during the first day a very interesting development. I saw a robotic system which was able to learn the movement of a monkey. I mean, we are talking about the year 1996. So I was like, boy, that's it. That's it. United States of America. That is why. And then 2 days after this visit to the lab, PhDs of that lab came to me and told me, oh, yes, could you do us a favor? What? I should do you a favor? Yes, could you compute for us this system? I asked him, you didn't compute this before you start to build? No. And they told me, we heard you are coming from Germany. You are able to do this kind of computations. And I guess, but how did you build that? We just tried and tried and tried, and we destroyed several times these robots. So they used to have lots of money, I saw. And they used to work with trial and error in the engineering. But they knew a German engineer can compute. And they came to me. It was like so, I felt so big smile. That was one experience. And the other experience was, I think we should be sometimes not so, we pay too much attention to everything and want to be 100%. The reality is not 100%. And you can be successful and achieve your goal also with 95%. And we are very fast at the point of being 95% perfect, but we waste time because we want to become 100%. That is what I learned as well.
Thank you for that insight. That sounds like a good rule and a lesson learned, definitely. We are in Stuttgart, the city of Stuttgart. Yeah. And with all, with the industry around, the ideas around, the companies around, the people around, and your title as tomorrow's maker, ein Übermorgenmacher, looking ahead the next 10 years. Mm-hmm. What could Stuttgart, the city of Stuttgart, be known for, and what should it be known for in terms of innovation?
Mm-hmm. I have a vision. So,
and please share it with us.
Actually, I have many visions. That's my main problem. But one of the first visions.
Give us one.
I have too much vision, but I think I don't need to go to the doctor. Anyhow, the first vision is 2012. It was just our institute working in that field. And I knew 2 other companies in Baden-Württemberg working in the field of wireless power charging. So today, there are a huge amount of companies and researchers are working in the field of wireless power transfer. And there are also companies, they are moving to our state, in particular to our city, because they know they are going to get the researchers from this university and they can cooperate with us. We have lots of international connections to the other countries working in the field of wireless power transfer, other companies. So my vision is that one day the city of Stuttgart could call itself the wireless power city. That is one vision I do have. It's a very big vision, but maybe they like it. When they call themselves the wireless power land. And I see this huge density of the companies working here in this field. Okay, that was in terms of the city. But I have another vision. How can we use the wireless power transfer? What can what can be? I mean, just charging electrical vehicle is now possible. It is, for me, okay, it must come out somewhere, but it's for me not something I wouldn't say, okay, it's a great challenge to realize it. Of course, it's a challenge to increase the power. For example, we have now limits with the power, and if you want to go in direction of the fast charging, we have to increase it, and it's still subject of the research. But I'm thinking to apply this technology for drones, but not only for drones, just to charge them somewhere. My vision is to use drones as flying robots in the production. And to save energy, I don't like the robots working together like a swarm of the beams and so on. I don't like them to come back to be charged. I want them to stay there where they work. And then a charger drone, which is larger and bigger, will come to them and charge them in the air wirelessly. That is a future project and one of my visions. And I think, okay, it's something not for even, maybe for übermorgen from now on.
Maybe for übermorgen. It sounds to me, it reminds me what we see sometimes in movies or documentaries, when planes in the air also come and fuel other planes to keep going.
Yeah. And I also think we can also apply another type of wireless power charging, not this kind of charging we use for electrical vehicles, but there are also ideas to use the solar energy in the atmosphere and to beam the power to the Earth. It's a different area. It's a microwave technology. It's not totally my technology, but it could be combined. Or we could also use the wireless power transfer to transfer energy between the satellites. So, just to give you
some of those that may be, that will be upcoming, perhaps. And of course, I like the one about the wireless city Stuttgart, and also connection to the land. Why not the power land?
Yes,
the wireless power land.
The wireless power land, yes.
Baden-Württemberg.
Maybe it's not very far away because 2028 we are going to be the host of this IEEE conference for wireless power transfer. So that's in the near future. In very near future, yes.
For now, to end our conversation, we have collected 7 questions. We call it Moment 7. Moment 1. Spätzle or Maultaschen?
Maultasche.
Moment 2. One thing you could change about the world would be?
To bring freedom in the world.
Moment 3. Do you have a recommendation for a book, a music, movie, theater, or museum visit?
The movie, E.T. Sorry about that, but I love E.T. A book, Quantum Technology.
Moment 4. The best advice that you have ever received was?
My supervisor, PhD supervisor, told me, I will say this in German because he was German and I will say it in English. Kommt Zeit, kommt Rat. If the time is there, so the solution will arrive. So this advice I use very often because we all are very impatient. So kommt Zeit, kommt Rat.
Moment 5. Your favorite place at the university is which one?
The forest, campus, Vaihingen Forest.
Moment 6. Please finish the sentence. If I could start all over again, I would do the following differently.
Nothing differently.
And finally, moment 7. Also, to complete a sentence. Thanks to my studies, I know that...
the world is not perfect.
Professor Parspour, thank you for letting us know about the world, for letting us know that we should not always aim for 100%, but that we need to get going, sometimes also in different directions, and for sharing your visions about what is upcoming next, whatever is made of science.
Thank you very much for having me here. Great to listen to your questions and to come talk to you. Thank you very much.
Well, likewise here. Thank you. And to our audience, thank you for listening in today. Please stay tuned also for our next conversations that are always based on what is made in science. My name is Wolfgang Holtkamp. Have a great podcast day. Goodbye and good talking.